Yeah.
We did our group project on our remote
Now
control
we can
fan.
see.
Our group members are Amir, Icko, and Mohammed. Our ceiling fan, RCF for short, adapts modern ceiling fans to become smarter and better. It adds automation features as well as wireless control. It adds more comfort to everyday living and removes the inconvenience of having to move around to operate your ceiling fan. The objective of our project was to make an Arduino-powered, remote-controlled, temperature-sensitive, light-sensitive Arduino module that would be able to adapt any modern ceiling fan to become smarter and better.
The goal of this project was to attach an Arduino along with an infrared receiver to a fan and lighting fixture which would allow for remote control access from anywhere inside the room. The benefit to having your lights and fans remote controlled rather than controlled with a traditional pull string is that it provides a much larger range of accessibility to the fan. In addition, shorter people, or people that can't reach the pull string due to a disability, are also able to use the fixture with ease. With stronger remotes, fan and light control outside the room where a fan resides in is also possible, and with further customization, it could be possible for one remote to control multiple fans from anywhere inside the house.
In our survey, we asked how often people use their ceiling fan or lighting fixture. We found out that more than half of people use their ceiling fan often or always. This gives us the opportunity to target a very large audience, as our product would be applicable to most people who use their ceiling fan or lighting fixture often or always.
So the problem, as stated before, is Amir has a broken fan and lighting fixture in his room that he would like to replace with an Arduino powered device, which would allow him to wirelessly control the fan and the lighting in his room. So with traditional pull strings, obviously you would have to get up and physically pull on it in order to change the setting of the fan or the lights. And we saw two aspects of this that we could improve. First off, the remote control improves accessibility in terms of being able to control the light and fans from anywhere inside the room. The second thing that we saw we could improve was that with pull strings, in order to change the speed of the fan, you would have to pull the string, then wait to see what speed the fan is spinning at, then pull and wait, and pull and wait. And if you pull the string just one too many times, you'd have to repeat the entire cycle all over again. So with the remote, this enables you to immediately set the speed of the fan to whatever speed you want. So here's our Gantt chart. We broke up our project into basically phase one and phase two, where phase one is a lot of the concept, the theory, and the designing, getting all the materials, and basically the pre-development portion. Whereas phase two is the coding, the building, and the implementation and testing of all of the prototypes and everything. And here's our PERT chart for the remote controlled fan and light. Here's our purchasing list. We bought the Elegoo Mega Kit, which comes out to $68.66, and from this we use the Arduino Uno controller board, as well as the infrared receiver module and the remote control in our product. In addition, we used a lot of the components like the LED and the breadboard to work with our prototype and testing. We also had to buy two 5-volt relay modules for $4.39 each, which means our total comes out to be $77.44. Here are the components from the Elegoo Mega Kit that we used in our actual project. We used the Arduino controller board as the main brain of our project. We uploaded code into that which allows the infrared remote and receiver to control the fan and the light. In addition, we needed to buy two 5-volt relays to connect the controller board to the fan and the light fixture.
Here is a picture of the space available to us to fit our project. Here are some pictures of the original components in our fan for documentation purposes. This fritzing diagram represents the prototyping board used for this project. We have our input from the IR receiver going into pin 4 and the output to our LED at pin 3. The motor is simply demonstrating functionality that could be implemented in the future. The IR receiver receives modulated infrared waves and changes its output. The receiver that we used for this project is the VS1838B with a built-in filter at 38 kHz and a working voltage between 2.7 and 5.5 volts. We used the Arduino's 5-volt output. The receiver distance for this module is 22 to 25 meters, which is more than enough that we need for this project. The pin layout includes pin 1 being at the output pin, pin 2 being the ground pin, and pin 3 being the high voltage pin. The VS1838B outputs high by default, so a PNP transistor indicated in the diagram by Q1 is needed to reverse the signal. R1 is used to provide proper biasing to the transistor. R2 is used to limit the amount of current passed through the LED at D1. The capacitor at C1 is used to ensure that the current only flows in one direction. This switch statement is used to decode the output of our IR receiver. It takes in a hexadecimal value representing the output from our IR receiver module and returns the corresponding button that was pressed on the remote. Here's a picture of the prototyping circuit board we used for this project. Here is a picture of our Arduino wired into our light. As you can see, this is not a permanent solution, but it does demonstrate how the wiring would be put into place. Here is a demonstration of our project in action. As you can see, I can turn on and off the light by the simple press of a button from our remote. Indoor lighting is only ever used in the early morning or evening hours. Because of this, a device that is able to sense the amount of light currently in a room and turn on or off the indoor lights accordingly could be very useful in saving electricity and reducing light pollution. The same effect could be achieved by using a remote control that would ease the access to changing the lighting in a room. An indoor fan is only needed when the temperature inside the room exceeds an uncomfortable temperature. Because of this, a device that is able to sense the temperature in a room and turn on or off the indoor lights accordingly could be very useful in saving electricity and maintaining a healthy living environment. Overall, this project taught us a lot about how to code with Arduino, especially when handling multiple files and large switch statements. It also taught us a lot about how the IR receiver works and how to deal with modules with Arduinos. It also taught us a lot about teamwork, communication, and how to properly organize a large project, such as the one that we took on for this assignment.